Hello, my name is Miss Loving Math, and we're going to go over some integral formulas today. So I will be going over these two formulas right here. I will be doing the explanation, and I have around 8 questions for all of you. If you only specifically want the explanation, check out the description as well. If you want a certain problem, check out the description. I write down both the timestamp and the question that I will be showing off. So feel free to click on that. I will be going over this first, and then I'll be going over this one next. So, like I said, please check out the description. That's where I basically timeline everything. So let's get to it. This is the first integration formula that I'll be going over, the integral of dx. So normally all formulas when it comes to this particular one has a 1 dx. Definitely feel free to check like other formula sheets. But I particularly did not put the number 1 in there, and there's a reason why. There are many problems that just actually just has another number, or a just, let's say for an example, number 3, number 5, number 21, and they will all work. For this particular explanation, I will only be doing number 1. So I'm going to place the number 1 right now. And the formula is equal to x plus c. Let me go over this particular formula a little bit. So basically, imagine that we have a invisible or a x to the power of 0. X to the power of 0 equals 1. So by doing the integral of 1 dx, we're turning that x into an x to the power of 1 divided by 1. And that's how we get that x to appear. That's not really how it is really portrayed in the textbooks, but I just like to use that in case I ever forget. But let's say, for example, we did have a number, like let's say we had like 5 dx. Then instead of that invisible 1 that we have here, now it's dx plus c. Um, for your reference, the c is a constant. And what that means is because we don't know exactly what this c is supposed to equal, keep in mind, as you get into like calculus 3 and beyond, you'll definitely be placing some stuff in to c. But for just this simple integral formula, we will not be putting anything in c. So we use the c as a placeholder. And yeah, that's basically how you use this particular formula. Like I said, if you like that thing that I did, which is just the imaginary, you can do that. Which is just the imaginary 0x, and then you're just adding the plus 1. Feel free to do that. The main thing is just remembering that doing the integral of a number dx equals that number and then x to the plus c, which is the constant. I'll be going off to the next one next. So this is our next integration formula. So we got the integral x to the power of n and then dx. I want to go a little bit more in detail when it comes to the x. So the reason why we have the dx and the x is so that you know exactly what you need to integral or what you are allowed to integral. As time go on, you will find formulas like this where like you get just like d dx and then dy. That means that you will only be able to allow to do that particular integral. So definitely pay attention to that later on. But for right now, we only need to worry about is the x and the dx. So thankfully, don't worry about that. But I just wanted to explain to people before we get there. The x is basically our variable. The dx is what we are allowed to do the integral or the derivative as in other topics. And then the n is basically our number, aka our exponent, that we will be seeing as time goes on. And when we do the integral of this particular problem, there's multiple ways to write it. I personally like writing it this way. Okay. So what ends up happening when you do the integral of xn is that n is going to add itself by 1. So these two are the exact same number. I put the 1 here because imagine like there's an invisible 1. As time goes on, you're going to see other formulas that contain like 5, 7, 11, and that's basically where you're going to store that number. So let's say instead of a 1, it was a 5. We would just replace the 1 with the 5. It really depends on what's in this particular section to figure out what we're going to put in there. And then from there, we got our C, and our C is the constant, so we just have to put a plus C when we do the integral. I hope that makes sense. I will definitely be going plenty of problems in a second, going from just one variable all the way to like 3 terms. So don't worry, we will get started on that right now. So this is our first problem. We got to do the integral of x to the power of 2 dx. So let's just look back at our previous formula, and we know that the integral of n x to the power of n dx is equal to 1 over m plus 1 and then x n plus 1 plus 5. So let's think. So let's consider that our n is number 2, and thankfully x is by itself, and we have that invisible 1. So let's just remember that. So that means when we do the integration of this, we will get 1 over 3, because remember we're adding the plus 1 to n, x 3 plus c. When you get into this particular situation, just leave it as a formula. There's nothing really you can do. If you can simplify it, that's great, but for this particular formula we cannot simplify it, so we will leave it like that, and it is correct, so don't worry about it. But alrighty, next problem, number 2. Alrighty, next problem, we gotta do the integral of 6x to the power of 5 dx. This one should definitely be a little bit similar to the first problem, so let's get to it. We notice that there's a 6, so we will leave that 6 over there. We notice that from our formula that the n is a 5, so that means to do the integral we are going to have to do a plus 1, which is going to equal 6. So the integral of 6x5 dx equals 6 over, remember we're doing n plus 1 here, that means it's going to be 6x, and then once again 6 plus 1, 6 plus the constant, so c. Because we got 6 over 6, that means that we are allowed to simplify it, which is going to equal 1. Make that 1 invisible. So we were gonna just get rid of this. So now we get 6 to the power x to the power of 6 plus c, and that's our answer. We are going to definitely be still sticking with our one term. So next problem is going to be again a similar thing. Number 3, we got to do the integral of 3x to the power of 5 dx. So as we know, we got a wonderful 3 right here. We're going to leave that alone. Then we got n equaling 5. So we gotta plus 1 it when we do the integral, which is going to be 6. And don't forget, when we do an integral, we're going to do our constant as well. So that means that when we do the integral of 3x to the power of 2 dx, we're going to get 3 over 6x to the power of 6 plus c. We can definitely simplifying it. The over 3 over 6, which we're gonna get a half. So that means our final answer is half x to the power of 6 plus c. If you're not sure whether or not you should simplify or not, talk to your professor and ask them how would they particularly like their your work to be shown. There's many people that just want you to keep it as 3 over 6. Some people just want you to simplify it. Definitely talk to your teacher first and get a correct answer, because I wouldn't want you guys to miss points just because the teacher wanted you to do it another way. So talk with your teacher. We're going to do another problem. Okay, so this is our last easy problem. So let's get to it. As you know, we gotta leave alone the 5. Our 3 happens to be our n. So let's do that. Plus the plus 1, which equals 4. So that means the integral of 3x cubed dx equals 5 over 4 x 4 plus c. And it's already simplified as much as we can do, so this is the correct answer. Alright, off to a more medium-sized problem. Okay, so this one's definitely a little bit more difficult, but we got this. We're smart cookies. So let's get this started. When it comes to these particular problems, I like to think of it one at a time. So what I mean is that we got this and then we got this. So that means that we're going to do the integral of 2x and then we're going to do the integral of 3. So let's do the 2x first. So we know when it comes to the 2x that our n is equal to 1. Our little number happens to be 2. So that means when we do the integral of 2x dx, we're going to get 2 over 2, because remember, we gotta do the plus 1 here, x 2. I'm only separating into chunks. I promise you there's a reason why I'm doing this. And then we got our 3. That means that our number happens to be 0 and our number is a 3. So that means when we do the integral of 3 dx, we're going to get 3x. Now we're going to add them all together. So we got 2x plus 3 dx equals 2 over 2 x to the power of 2 plus 3x plus c. Because we're doing the integration, we gotta still have a constant. Now we can definitely simplify it. So that means our answer is going to be x squared plus 3x plus 3. What really helps me out here is just focusing it one at a time when it comes to these particular problems. I think that people get overwhelmed in the very beginning, but it's pretty much the same formula. It's just now you got more terms to involve. So definitely take your time, just worry about one to another, and you got this. But this is going to be your answer for number 5. We got question number 6 now. I did put some little parentheses around our integral problem. There's many problems out there where they do have this. This is just to represent that you're integrating this whole section. So I wouldn't worry about it too much. I just put it there just to show it off a little bit. But this is what we got next. So we can definitely see we have 7x cubed and then 5x. So let's focus on 7x cubed first. So we got 7x cubed. We know that our number is number 7 and the n happens to be 3, so that means n plus 1 equals 4. So overall, that means that we're going to get 7 over 4 x to the power of 4. Then we got 5x, so that means our number is going to be 5. That's the one that we step off to the side. N is 1. N plus 1 equals 2. So that means we got 5 over 2 plus 2. So if we combine it all together, the integration of 7x cubed plus 5x dx equals 7 over 4 x to the power of 4 plus 5 over 2 x to the power of 2 plus c. And there's nothing that we can really simplify here. So this is our answer for question number 6. Okay, so this problem is definitely more difficult than the last 6 problems that we've been doing, but we got this. So we got to do the integration of 8x to the power of 2 plus 3x plus 5 dx. So instead of doing it 2 times, let's separate it 2 times. Now we gotta separate it 3 times. I will start now just writing it the way that it's normally supposed to be written when you come to these problems. I've been showing them in a more simpler way, but I'm just gonna go more in the typical way that it goes. So we got 8x to the power of 2. So we know that our dx is 2. So that means that our plus d, I mean our n equals 2, so our n plus 1 equals 3. We got our n plus 1 here, invisible 1. So that means our n plus 1 equals 2. And there's no x here, so that means that um there's no n. So n equals 0. And then n plus 1 equals 1. So let's get to it. Remember that our formula is um, x to the power of n equals 1 over n plus 1 x n plus 1. So that means the integration of this problem will be 8 over 3 x to the power of 3 plus 3 over 2 x 2 plus 5x plus our constant, so c. Based off what I can see here, there's no other way to simplify this. Sadly, we get it stuck in fractions, but that's okay because that's the simplest way we can do it. So this is our answer for number 7. Like I said, if you were having a difficult time just figuring this out, definitely just separate it by chunks. You know, there's nothing wrong with taking your time. The thing is just getting it right. We're going to go off to our 8 and our last problem. So we got to do the integration of 6x to the power of 2 plus 8x plus 2 dx. So let's get started. I'm just going to show these individually to show how to do the integration. So we get 6x to the power of 2. So we know that our n is a 2 and our number that we gotta step to the side is 6. So that means that we're gonna have to do like 6 over 3 because we gotta do the plus 1 from n, x to the power of 3. Right here, our n is 1, our number is 8. So that means we gotta do 8 over 2, remember the plus 1 from n, x 2. Lastly, we got our 2, our n equals 0, our number is 2, so we got 2x. So that means the integration of 6x to the power of 2 plus 8x plus 2 dx will be 6 over 3 x to the power of 3, 8 plus 8 over 2 x to the power of 2 plus 2x plus the constant c. Because we can simplify it, I'm going to do the simplified version. So 6 over 3 is 2, 8 over 2 equals 4, and these two are already simplified. So that means our whole answer, our simplified answer, is 2x of the power of 3 plus 4x to the power of 2, 2x plus c. And that's our whole answer. Thank you so much for watching this YouTube video. I really do appreciate it. Please like, subscribe. I definitely will be continuing to do more wonderful formulas like this If you have a problem or concern, feel free to comment it down below. If there's a particular topic that you want me to go over, or if there's a specific problem you want me to go over, please let me know. Most likely I'll create a video or just message you backly. And thank you so much. I really do appreciate all the love and support. And make sure to remember, mistakes are necessary for us to learn. So please make as many mistakes as you can. That's how we learn. But this has been Miss Lovey Math.